1 second. So today we're going to start as gradient descent, which is the last algorithm of linear part in regressions. Okay, so gradient descent algorithm. Okay, so I will explain. The first time when I explain, you don't understand, guys. I split these explanations in two parts. Okay, I split these explanations in two parts. The first part and second part, let's discuss each and every parts. All right. So what exactly mean by gradient descent? Let's discuss. Yeah, just 1 second. Just one moment. Yeah. So gradient descent optimization algorithm, okay, is an algorithm that finds best fit line for given training data set. Okay, best fit line for given training data set. So what exactly mean by this? So let's understand one by one. Y equal to mx plus c. Okay, y is equals to 2x plus 3. So x is what? Independent variable, right? So when I interpret 1, 2, 3, 4, 5, then I get this value 5, 7, 9, 11, 13. Yes, so this is what we got. So this is called traditional programming. Now what is machine learning? X 1, 2, 3, 4, 5 and y 5, 7, 9, 11, 13. Then y is mx plus a. We got this. Agree? Yes, team. I hope you understand. Now let's say this. What is meant by global minima? So this is what the gradient descent curves looks like. This is what the gradient descent looks like. Let me tell you, if I drop a ball, if I drop a ball here, it will reach out and then it will come back, it will here go, and finally it will reach to this point, isn't it? So this point is called your global minima. This point we called as a global minima. So what exactly these initials, weight, all those things we're going to understand, guys. So do you remember one time I asked a questions, if I plot the multiple line, okay, which line would decide as a best fit line, guys? Which one? Which has minimum error, right? Which has minimum error, that fit as a best fit line. I mean, did you see what we call this is as what we call this? Mean squared error or MSE OLS. Also we called as, we measures this all things in R squared and adjusted R squareds. Yes, guys, online team, I hope you understand, right, guys? Now, as I mentioned, this MSE is called as cost functions. What is cost functions? This MSE is called cost functions or loss functions. Understand? So loss, cost, MSE, and OLS all are equal. Okay, all are equal. In interviews, different people will ask multiple terms, but you can easily understand all those things, guys. I hope you understand. Clear? So I can say gradient descent is an optimizations algorithm that finds best fit line for a given training data sets. Do you see, if I have around more than 3 lines, how do I find a best fit line? Because of cost functions. Because of cost functions. I hope you understand, right? Now, so y equal to mx plus c. Okay. If I gradient descent, if I show in 3D, 3 dimensions, what is m? Slope, b intercept, and this one is called cost functions. Okay, I will give you math intuitions behind how exactly the graph has been made. Okay, so in this one, when I drop the ball, it will reach to this point, right? This point is decided as a global minimum. For example, if I plot this one line, it's going down directions. This is another line, multiple line, right? If I plot the graph, which one, how to decide a best fit line? So this is one line, this is another line, this is another line, and this would be the, if I make it into 2D, this would be the best fit line. I'm sure a lot of them not understand what I'm saying. Anyway, I'll get back to the topic right now. Yeah, this is at this moment, understand, we try to minimize the loss. What exactly? What is meant by loss? The difference between, what is meant by loss, guys? Loss equal to actual minus observed, isn't it? So in gradient descent in GD, we are trying to reduce the loss, okay, to reach the global minima. In interview, there is different questions. What is global minima and global minima and global maxima? So global maxima, I am going to explain in neural networks, right? Global minima, just let me go ahead. I hope you understand, guys. Yeah. So in this case, if I plot cost functions on y-axis, I mean XYZ, 3 dimensions, okay? If I plot this gradient descent in 3 dimensions, how exactly it looks like? It looks like a bell shaped, isn't it? It looks like a curve, and this point would decide as a global minima. So what exactly, I wanted to show you some of the graph. So gradient search points and lines. So if I keep increasing my intercept, see this M 0.21, B 0, my iteration is 6. So here we go. This is another point. So when I keep on increasing the points, I try to reach the best fit line. I hope you understand. Check this one. Check the 2 slides. Okay, when I keep on increase or reducing this one slope or intercept, what happened? I'm trying to reach the best fit line out of the many lines. I hope you understand. But still no problem. How exactly it's gonna get? So I will minimize at this moment. Now I am going to explain the another part of the explanations. Okay. All right. So let's understand the math behind this gradient descent. All right. So just 1 second. Okay. Listen very carefully. Any questions, just ask me. Okay. X-axis is weight of a person. Y-axis height of the person. All right. So these called actual data point. Actual or predicted? Actual data point. So let's start the simple data set. For example, on the x-axis, we have weight, okay? On the x-axis. And on the y-axis, we have height, right? Now the next one. If we fit a line to the data, for example, so what happened? Someone tells us the weight of the person is 1.5. Someone tells us the weight of the person is 1.5 pound. So if I plot the line, height will be generated here? Yes or not? Agree? So this is called 1.9 tall. Online team, I hope you understand everyone. Yes, guys. So if someone tells the 1.5 weight, if I plot the data points, I will get the height as 1.9. The next step. The next one. So what is the y formula? Y equal to mx plus c. All right. But before I'm going to start at this moment, assume for at this example, let's just plug in the least squares. Slope is 0.64. Understand? I take an example. M is 0.64. Understand? Please. Slope is 0.64. Clear, guys? Now, let's do this. So what is the predicted height? Y equal to M is 0.64 into weight. Understand or not? Let's do this. If the line touch to the origin, what is my intercept? 0. Agree? If the line, I'm not saying this is a best fit line. Understand, guys? I am not saying this is the best fit line. I'm saying if this line is touched to the origin, then my intercept is 0. Yes, guys. Now, let me compute. The first thing we do, pick a random value for the intercept. This is just an initial guess that gradient descent something to improve upon. I mean, let me introduce it. Intercept is 0. In this case, we will use, but any number will do 0. All right, guys. And that gives us the equations for this line. So if I solve this one, if this is my, I'm not saying best fit line, I'm saying the regressions line. In this case, so this is actual, this is predicted or not? Agree? This is actual, this is predicted. In this example, we will understand how the line fit the data with SSR, sum of square residual. I told you, do you remember? In ANOVA, when I told you, I said when the time comes up, I'll explain SSR properly. Yeah. Now, let's understand. I'll take one point. I'll take actual I have. Sir, can you explain this one more time? Come on. I already explained you. Okay, just let me do it. So what I trying to say, guys, just 1 second. Yeah. So I have 3 data points. Yes, Pratyush, I have 3 data points. This is actual or predicted. This is actual. All right. And one line, regressions line touched to the intercept, isn't it? At this demonstrations, we take slope as 0.64. Understand, Pratyush? We take slope as 0.64. Now I take a, let's calculate. So predicted height equal to 0 intercept plus 0.64 into weight. Everybody's clear up to this? Yes, guys. Now let's go to the next part. Let's go to the, in this example, we need to calculate SSR, sum of square residual. Now listen to me very carefully. In machine learning lingo, the sum of square residual is a type of loss functions. Understand what we call? That's what we say, loss functions equals to cost equals to MSE. Clear? So just understand this one. So we'll start calculating the residuals for the 1 point. In the 3 points I have, right, guys? The first point, let's do this. This is actual or predicted? 0.5, 1.4. Actual, this is actual. Yes, this data point represents a person with weight 0.5 and height 1.4. Now let's do this. We got the predicted height, isn't it? This is height or not? The point, the line. Now let's do this. In this case, we get the predicted height, the point on by plugging weight 0.5. What is the weight of the person? Predicted height equal to y mx plus c, right, guys? So what is weight over here? 0.5. I hope you understand, because x is 0.5, y is y. This is actual, this is x and y coordinate, guys. I hope you understand or not. Yes, Pratyush, yes, online, guys. Very simple. This is height and I fit into this equations. Now, when I check this one, so here predicted height equal to 0 plus 0.64 into 0.5. Clear this one? Clear, guys, this part? Now, can I get the predicted height? 0.32. Can I get the predicted height? Team, are you understanding? Yes. Yeah, this is called predicted height. I got the predicted based on actual height. Yes. Now let's do this. This residual is the difference between observed height and the predicted height, right? Now, so if I compute this part, so this is what predicted height, residual. So what is the SSR? At this moment, I compute only 1 point, isn't it? How many points we have? Another 2 more points we have. So do I have to compute all the points or not? Yes. So the residual is 1.4 minus 0.32. So the so this is what the residual is, 1.1. Guys, clear? Everybody's understand? So residual is 1.4 minus 0.32 is 1.1 for the first point. So let me tell you. So sum of square residual formula equals to 1.1 whole square plus, can I get some point or not? Can I get the residual for this point? Yes, online, guys. Correct. So next step, if I compute the same things, I got 0.4 square residuals. Understand? For the second point also, I got the residuals 1.3 whole squared. So 3-point residual I got. So if I sum up, in the end, 3.1 is the sum of square residuals when the intercept is 0. Guys, clear or not? When the intercept is 0, I got the residual is 3.1. So if I plug it in this one, sum of square. Now, this is what my residual points I got here, guys. Understand or not? So in the 3D, this line, let me tell you, this line I got in 2D, but in 3D, I am going to get this line like this. So is this best fit line? Is this best fit line, guys? No. I hope you understand or not. Now let's do this. Let's see the interesting part is. Oops, 1 second. Let's understand this. If I increase the residual 0 to 0.25, all right, let's do this 0 to 0.25. Okay, so this is the regressions line. Now I have to check residual for all the 3 data points or not. Guys, are you clear or not, everyone? Yes, Pratyush, I hope you understand now. Arshad, Yasin, everyone, guys. Sunita, okay, Pawan, all of them, just give a quick confirmations. I'm just trying to increase the residuals from 0 to 0.25, and let's do this. I'll get another cost functions for this 0.25. The same calculations. I need to compute all the residuals for different one. Now the next one, what happened if I increase my intercept from 0.25 and 0.5, what is the residuals again? And if the intercept is 0.5, I got cost functions for this line. I go here, this line, I got this one, this line, I got this one. All right. And for increasing the value for the intercept, we got these points, right? So now let's go back to the another one, 0.75, 1.25. Correct. Get it, guys? Everybody get it? So check this step count. The step is high or not? Little bit bigger step. Now smaller step. Now very minimum step. Yes, guys. To try to reach the global minima, the step size should be very minimal. Okay. This concept is called learning rate. What we called? Learning rate. So this is what your technical questions, guys. This is what your technical questions. So let me tell you, whenever trying to reach the global minima, just one moment. Oops, it's got stuck. Just one sec. Give me a second, guys. The system got hacked. Yeah. Kirtana, are you understanding? Are you practicing? Just one second. One moment, guys. Oops. Yeah. So let me write down whenever trying to reach the global minima. Again, just one second. One moment, guys, one moment. Trying to oops, just sorry about that. Just 1 second. I think the battery is yeah, here we go. Whenever we're trying to reach the global minima, what happened? The step count should be the step count should be very minimal. So this concept is called learning rate. All right. So in the learning rate, in the parameters, guys, whenever we declared, when we work on random forest and all those things, we should declare the learning rate is minimal means 0.001. Understand or not? 0.01 is minimal or not? Yes, guys. So this should be your learning rate. So what we understood today, so when you plot this cost functions, what exactly mean by this? So out of 1, 2, 3, 4, 5, 6, 7, 8, which one is your best fit line? Which one is your best fit line? The line, the cost functions, which is trying to reach this positions. This is called global minima. And this concept is called gradient descent. I hope you understand, guys. What exactly mean by gradient descent? Gradient descent is an optimizations algorithms, all right, to try to find the best fit line by reduce the loss. Okay. Yes, Sumit, clear? Understood? Yeah. So so all the time, whenever you declare these concepts, we're going to implement in neural network as well. Okay. Where we implement neural network, this is called optimizations algorithm. So in interview, if someone asks you what is meant by optimization algorithm, what you say? You need to say gradient descent and stochastic gradient descent. I hope you understand, guys. Gradient descent and stochastic gradient descent. Clear or not? So in these concepts, what we learned like loss, cost, and global minima. Okay. And step count should be minimal. All right. Should be minimal. So if I ask you another questions, what is the momentum? What is the momentum in gradient descent? What answers you will give, guys? What is the momentum in gradient descent? Learning rate only. This is called, in technical, they will tweak these questions like this. Yes. So this is called momentum. Momentum means in each and every moment, the step size is reducing. Yes. The step count is reduced. The step count is reduced. Step count is reduced. For example, this line, this cost functions I created from this line. So let me plot this line. So this line showing the directions towards downward, isn't it? So the next pointer should be this one. This cost functions is generated from this one, right? So this is the pointer. Now this cost function is generated from this line. So let me show the pointers. And this cost function generated from this line. So this would be the pointers. And now this cost function, which is global minima, it's like this, and this would be your best fit line. Clear or not, guys? Clear? So at this moment, if someone asks you without scikit-learn, okay, without scikit-learn, can you build ML model? Yes or not? Yes or not, guys? Yes, we can build, and that concepts we called as gradient descent. I hope you understand. But now, very simple questions. In only 3 data points, okay, how many data points? In only 3 data points means this is one person height and weight, this is another person height and weight, this is another person's height and weight. Yeah, only 3 persons. Don't you think the math is so long, isn't it? Yes, guys. But in real time data, what happen if you have 20 lakhs rows? If I compute all these like this way, my project is never going to end, isn't it? Yes, my project is never going to end, guys, on these cases. So let me explain this one. I hope you understand before I talk up to the another concepts. Of the points that we calculated for the graph, this one has the lowest sum of squared residual. This one has lowest sum of squared residuals. Clear, guys? Yep. So let's go back. So this is what we understand. I don't take more in detail. This is good enough to understanding all those things, guys, right? Clear, guys? Now let me talk about, so this is what I explained. Now I hope you can understand. If I show this pointers, what happened? Another questions. What happened if I have equal step? What happened if I have equal steps? Equal steps, isn't it? This is equal steps, equal step. Am I trying to reach the global minima? It will, but time consumption is very high. It will. So let's say, guys, no, it will multiple iterations is required. Yeah. So see this, one step, same step, again, same steps, again, same steps. The first time you never reach the global minima, isn't it? It will jump up. It will jump and again it is goes up. And the same step, I mean, many iterations you should declare to reach the global minima, guys. So that's why this is what your interview question is. What happen if the learning rate is not minimum? I hope you understand, guys. What happened, the learning rate is chances of skipping. Correct, Arshad? It won't skip, but the iteration is gonna high. I mean, this might be overfitting or some kind of, I mean, accuracy will fluctuate on this scenario. Yes, Arshad? Yep. So this is called momentum. So all the time, the learning rate should be very minimum. Understand? So let's go back to this one. See this. This is a compare to graph. Compare to graph. Did you see this, guys? See. I think everybody know IPL matches, right? If a player play from long distance, first he do a big steps, right? Then big step, then this is the line. Yeah. When he reach to the line, his step count is very minimal, isn't it or not? Or else this becomes your no ball if he cross the line. Understand or not? Agree? Everyone is agree, guys? So this is what exactly the gradient descent concepts. And now I hope you understand or what is cost functions, all those things. Yes, guys. Online team, are you guys are clear? Everyone? Earlier it was 38, but now 34. I know that because when the day end, I have only 10 people. I know that I told you on the day one. Okay. Yes, Sindhuri, I hope you're clear. Shiva, Ansari, Azad, Rohan, Ramya, Washim, Yasin, Jaid, everybody, guys. Okay, let's go back to the another topic. So gradient descent, we understand. The next one, Okay, in statistics and machine learning and other data science fields, we optimize a lot of stuffs. Yeah, so this is optimization algorithms, guys. So now just one moment, one moment, one moment, one moment. Yeah, I think we done this part. Just 1 second. Okay, done. Now let's see this. Let's see this. For only 3 counts, only 3 data points in our example, we only had 3 data points. So the math didn't take very long. Agree? Yes, team? Now the next one, but when you have millions of data points, it can take a long time or not? Does the gradient descent works on this case? So that's what I'm saying. So there is a thing called stochastic gradient descent. I hope you understand, guys. When you have less data points, the gradient descent will work. But when you have more data points, the gradient descent is very slow. Understand? So that's why we introduce concepts called stochastic gradient descent. What exactly it will do? It uses a randomly selected subset of the data every steps, right? For example, so can I say big data gradient descent is very slow? Okay, so what I say, the big data, the gradient descent is very slow. Okay, I hope you understand. So there is a concepts called stochastic gradient descent. So let's understand what exactly mean by stochastic gradient descent. So what exactly it will works and how exactly it will works. Now let's do this. In stochastic gradient descent, okay, see, there is a lot of maths, guys. Every ML algorithm is a math, but you no need to remember all those things. Okay, and I'm sharing this one because I am giving you the core part of the gradient descent. I hope you understood, right, guys, what is meant by GD, and so that you can explain. But if you see same things in book, if you study yourself, you don't understand, guys. This is to be honest. Yeah. So now, what exactly is stochastic gradient descent? For 3 data points, the math didn't take long. But if you have more data functions, we have to reduce the loss or not? Yes, guys. For let's say we have 23,000 data points, and what if we have 1 lakh data samples? So if I compute for 20,000 derivatives, we're trying to reduce the loss. If I talk about maths, we need to understand all these concepts, guys. Since it common had at least 1,000 steps, these many terms we need to compute as a calculations. Can we do this, guys? It is a highly impossible for a human to compute all this kind of derivatives, isn't it, guys? For each and every data points. So that's the reason for big data gradient descent is slow. Understand? For big data, gradient descent is slow. So in real time, we don't use the gradient descent. So that's why we have to use machine learning frameworks, which is called sklearn, scikit-learn. Yeah. So this is a concept called stochastic gradient descent comes in handy. So let me tell you, in gradient descent, how many points we pick? Only 1 data points, right? So if I have big data in stochastic gradient descent, rather than it will take 1 point, it will pick, just one moment, random points. What I said? Rather than 1 point, it will pick random points, guys, based on his interest. Yeah. So 4 data points. So stochastic gradient descent is especially useful when there are redundancy in the data. So for example, in this example, we have 12 data points, isn't it? So if I take a 12 data points in gradient descent, I have to compute the math for 12 times, isn't it? But here, what stochastic is done, I create 3 cluster. Cluster means what? Group. 3 group, and then I compute the cost functions for sum of square residual for each and every data points, guys. See, then I'll check this one. If the intercept is 0, I got my cost will be generated like this, isn't it? Now, if I change the intercept to 0.25, another cost is generated. And this is the way I'll create my curve like this. And I'm trying to fit the global minima. I hope you understand, guys. What exactly mean by stochastic gradient descent? Yes or not? I know offline, a lot of people are feeling sleepy. That's okay. Yes, guys. For each subset, Arshad, I hope you're clear. Online, guys. Okay. Sushma, Washim. Okay. Now, what is the difference between gradient and stochastic? Then we need to use stochastic. Let me explain one more time. Any guesses? What is meant by batch gradient descent? What is meant by batch gradient descent? Okay, Nishchit, I hope you understand gradient descent, right? In stochastic gradient descent, what we will do, stochastic gradient descent, what we'll do, rather than 1 point, we will take 3 points, Nishchit. Yes, rather than 1 point, I will take these 3 random points. Random points. For each and every random points, we need to compute the step size intercept, something like this, using the background math. So just like regular gradient descent, stochastic gradient descent sensitive to the value choose for the learning rate. Yes, I just talking about learning rate. So every steps comes up. Let me show you how exactly create. Just one moment. I wanted to show up. This is 0. Then we randomly pick another point. Now another, this is stochastic. Yes, Nishchit, I hope you understand now. And the next one, it increased. Now it increased. Now it increased. And finally, I got the best fit line. Got it? This is called stochastic gradient descent. So what is batch gradient descent? Anyone? So let's say I have 1,000 data points and I want to give you to make 100 as a one batch. So how many batch you can make? And how do you fit this stochastic gradient descent versus batch gradient descent? I hope you understand. The same things, let's copy. So what is meant by batch? What exactly the batch will do? So in stochastic, we consider it as a random points, isn't it? But in batch, I can say 100 rows as one batch. Understand? So if I have 1,000 rows, 1,000 divided by 100, how many batch I can make? 10 batches, isn't it? So 10 batches means at intercept 0, I need to fit all these 10 batches. I get one cost functions. Agree? Yes, guys. Now I'll change 0.25. I get another cost functions. Agree? The same repeat steps will comes up and reduce the learning rate. And this would be your batch gradient descent. Clear, guys, everyone? Everybody's understand or not? So this one, Nishchit, I hope you're clear. So let me. So when you prepare a notes, just you can mention gradient descent versus stochastic versus batch. Let's click it. You get all these informations like this, guys. Did you see this? Did you see all the informations gradient descent? They try to reach the global minima. Yeah. Everything you guys will see the global minima. Okay, guys. I hope you understand. But now when you go back to the notes over here, if you see this, now open link in new tab. I mean, there's multiple informations. Which is faster? Batch gradient descent can be used for smoother curves, but stochastic gradient descent can be used when the data set is large. I told you just now. SGD we can use when the data set is large. I mean, that's what we say, big data. It doesn't works, right? Batch gradient descent converts directly to minima. When I make a batch, definitely it impact to the point, minima point. Yes, team, clear? So all those things, guys, we given here. Now, I will show you one code how to build a model without using cycle. This is okay. This is optional. If you want to practice, you can see. But let me show you guys one of the thing, like how exactly. Let's copy this and yeah. Just one moment here. The system. Yeah. So if you see this data sets, all right, what I say, house price, linear regressions from scratch. Gradient descent is a linear or non-linear? It is a linear, not a non-linear. It is a linear regressions from scratch with the gradient descent without scikit-learn. All right. So if you see this, NumPy pandas, right? And reprocess the data, x-axis, y-axis, and see this guys, how if you see this code, alpha equal to 0.01. What is meant by alpha? Learning rate. Did I mention step size here? Yes, guys. Iterations, 2000 iterations. Why? Because if I makes more iterations, there is no chance to skip the minima, isn't it? You can try m equal to y into size, y equal to mx plus c, then m equal to y into size, number of data points. What is m? Now np dot random seed function, set the seed. I told you, I think, because to make a constant value when you talk about randoms, yeah? Theta, pick some random values to start with. Okay, now gradient descent. Define gradient descent. X, independent, dependent, theta, iterations, alpha. Write a functions, create an empty list, and theta, and then write a for loop to calculate the cost functions. 1 by 2 into them. Did you see, guys? Oh my goodness, there's a lot of maths, isn't it? So without using scikit-learn, no machine learning model is exist. And we don't know, can we get a clear accuracy? No idea. No idea. Yes, guys. So that's why I'm saying, what is the cost function? This is the cost functions. Finally, I'll get this output. See this? What happened? I am trying to increase the cost functions from 0 to cost functions keep on reducing. When I reduce the cost functions, the accuracy will increase. Understand, guys? When I reduce the cost functions, the accuracy will increase. So this is what exactly the gradient descent is all about. Clear? So we're not going to do practical for this. We're just going to understand the conceptual part, and we understand. Tomorrow, we see support vector regressions, decision tree regressions, random forest regressions, regularizations, all those things we're going to understand one by one. Clear? Yes, guys. So at this moment, I'm going to send this code. You can make some small pointers to mention all those things, guys. Clear or not? Yes, guys. So now I hope everybody is up to date the task wise, isn't it? So let's post this over here and bookmark. So anybody is working on the 850 pages, guys? The one, I think somebody splitted the task based on user wise. No? Can you please start working on it? Let's discuss those things. Trying to connect. Now I'm connected. Okay, finally, Chakri. Yes, you joined late today. Received only 3 people done. Very good, Sinduri. You received 3 people done. Can you update over the sheets? Let me check it out. But in the meantime, I just browse desktop and sorry, you guys are at 10 a.m. Yeah. See, guys, I just created a folder. Okay. In the main home page, I created a folder, something like, did you see Python 850 pages codes? Guys, are you see this? Python 850 page codes. I mean, I'll do that. Thanks, Sundar, because my other students, they are doing it because he completed 360 to 375 pages, guys. If you see this, look at the way he worked, because I'll tell you what is the power of the book. So this one, it's clearly identify This is the Python 850 pages book code. Let's say the one, whoever working like this, I will mention his name and I'll share the screenshots, I mean, among the, with the group guys. So chapter 65, plotting with Matplotlib, he done this line space and he explained in the batch what he done, right? This would helps you, this would help you to improve your coding skills, guys. I hope you understand plots with all these things. Clear or not, guys? So if possible, you can also prepare 10 pages. Yes, Sumit, 10 pages, everyone. Sinduri, please keep follow. Every day we will discuss 5 minutes on it. What do you say? Is it okay, everyone? Can we discuss? Because these things, nobody will train you. No institutes will train you. I hope you understand. Imran, Sadiq, can we do it, guys? Yeah. You got the access, right? Imran? Yeah. Okay. So please, I think Sinduri given this task. Sumit, you also assign the task to everyone. I'll check it again once I get a free time and I'll again work on it, guys. Yeah. Everyone, 10 pages, 10 pages, everyone. Okay. Thank you and have a good day, guys. See you tomorrow and we'll work on support vector regressions. What exactly how the equation is get and all those things we understand. Yasin, clear? Yes, Yasashri, Nischit, Drakshayani, Sunita. Okay, Sushma, everyone, guys. Chandramouli Argha. Chandra has clear? You joined lately, you're not clear. No problem. Okay, see you tomorrow. And we're going to see the support vector regressors with some of the math equations we're going to understand. So, hi team. Please work on the okay, I post today's notes. Okay, please take down. The good, the one who completed Arshad, by the time now you got more expertise and it's addicted to learn the codes. Yes, I understand, guys. The one who completed, so they're, I mean, they are into different level now. I'm sure about it. Yeah. And thanks, Avinav, that the way you mentioned to the PDF to connect to the sessions. Okay. Yes, Shubham. Sorry, Shubham. Yeah. Okay. Thank you. See you tomorrow. Bye, guys. So we'll see SVR tomorrow and all those things and complete regressions as well. Please upload GD graph. I done. Ashok, I already updated Ashok. Just now I sent. Can you check and you can extract it? Okay. All right, guys. And can you share the support team number? Drakshayani, the support team number. Just one moment. I think I missed last two classes. Okay. Support team number. Just 1 second. I will post in the, or else I think I can be here. Just. You missed yesterday class? Okay. Please take care of it. Okay. Bye, guys. I think you can reach out to him. Okay. Good day, you too. I just sent it to you. Please check it out. You just call them up. Okay. Ask for help. Or else you can drop an email. Bye, guys. See you tomorrow. Okay. Yeah, yesterday he told me that's okay. Coefficients are getting 0, right? For them, no problem. That's you can express no problem. It doesn't impact them.
Can you open this? No, that is house price predictions I didn't work, right?
No, for that another one that.
That also you're getting the same thing?
Yeah, for 2 index only I got
Can you share the code in the classroom? I will check.
Okay, that is right.
Yeah. దీనికి మీరు 3.5 చేయాలి, 3.4 కి కన్వర్ట్ చేయాలి. నేను మీకు ఒక లింక్ పంపిస్తాను. హోండాకి వెళ్ళేసి ఇప్పుడు క్లాస్ ఉంది, జస్ట్ పింగ్ మీ. ఒకసారి రీసెర్చ్ చేయండి హౌ టు డౌన్గ్రేడ్ ద ప్యాకేజెస్.
ట్రై చేస్తే అప్గ్రేడ్ డౌన్గ్రేడ్ ఏది కావట్లేదు.
మీరు అనుకున్న నెవిగేట్ ఓపెన్ చేయాలి, ఇక్కడ మీకు ఆప్షన్ ఉంటుంది, చాలా టైం తీసుకుంటుంది. ఓకే, ఐ విల్ పోస్ట్ టుడే ఇన్ ద క్లాస్. నేను క్లాస్ రూమ్ లో పోస్ట్ చేస్తాను. ఎందుకు 3.9 వచ్చింది మీకు? ఓకే.